So the question has been asked in AIPMT 2008. It says that a thin rod of length L and mass m is bent at its midpoint into two halves so that the angle between them is 90 degrees. The moment of inertia of the bent rod about an axis passing through the bending point and perpendicular to the plane is defined by the two halves of the rod is. So basically in this scenario we're given with the rod, and this rod has length L and mass m. But then again, this rod is bent at a certain point, and we have to find the moment of inertia of this entirely new system wherein it is bent to the point such that the other two parts of this bent rod are equal in length. That means it's bent at its midpoint, which means this part of the rod is going to be L by 2 and the other part of the rod is again going to be L by 2. Now, we know that the moment of inertia of a rod about an axis that's passing through its edge is equal to 1 by 3 ml square. Now here we're going to have two different parts of the rod, and we're going to have a moment of inertia for two different parts of the rod. So for the first part, we're going to have 1 by 3. Instead of mass, the mass of this part is m by 2, and the length of this part is L by 2 and square of that. Again, same for this very rod as well, this very part of the rod as well, 1 by 3 m by 2 L by 2 square. Now 1 by 3 m by 2, 1 by 3 m by 2. This comes out common as m by 6. And what we have from the inside is L square upon 4 plus L square upon 4. This gives us 2 ml square upon 24, which is equal to 1 by 12 ml square. So that is the moment of inertia of this entire system when the rod is bent at its midpoint.